Hi folks, I'd like to share my experience with Raspberry Pi 5. I got my first Raspberry Pi 5 in mid-October and the second one in mid-November. They're both unique because they have very different cases. The first one was complete with power supply, keyboard, mouse and all the cables, and also the original Raspberry Pi 5 cooler with a fan and an SD card with pre-installed Raspberry Pi OS bookworm. I had to make a case for it, but it was very easy because I already had one plastics case. It was meant for Raspberry Pi 4, but I quickly realized that it was very easy to adapt for Raspberry Pi 5. And I did it in 5 minutes. You can watch the video. It works perfectly. But it's interesting to note that today they sell cases like this for Raspberry Pi 5. Of course, you won't have to adapt them, and they work perfectly with the original Raspberry Pi 5 cooler. But later on, I have discovered that there was not enough room for add-ons, so I inbuilt this case together with Raspberry Pi 5 into a much larger case, which I left open from one side for better cooling and to be able to put cables through. But on the other hand, I was able to inbuild a small hard disk with 232 gigabytes and also a homemade sound card that I've made from a microchip development board using USB speaker example. It might not have been an optimal setup, but at the time I was not sure whether a standard USB sound card for a PC would also work with a Raspberry Pi 5, so I've decided not to risk it and to make my own first because I've already had this hardware. It worked perfectly, and later on when I got the second Raspberry Pi 5 I also bought a standard USB sound card and it also worked perfectly. What about the battery for the real-time clock? This one was interesting because at the time it was very hard to order a battery because I would have to wait to get one, but I already had all the components to make my own battery assembly together with the battery holder and a diode. I needed a diode because my battery was CR2032, which is non-rechargeable, and I wanted to prevent it charging at any time on any circumstances. I know that charging must be enabled in the Raspberry Pi OS, but you never know what might happen if you install another operating system or if something goes wrong with DA9091 power management controller, so it's better to have a diode for a precaution. You can watch video Raspberry Pi 5 RTC battery to learn more and to make such a battery yourself. The next consideration for the second Raspberry Pi 5 was how to use it at all, because I've managed to order a bare Raspberry Pi 5 without a power supply, without anything, just the PCB. And this meant that I had to invent my own case as well. I had to find a suitable power supply. I already had some 4 ampere 5 volt power supplies and I decided to test them on this Raspberry Pi 5, but I was also concerned about its cooling. At first I was unsure whether a standard fan would provide enough active cooling for it to work normally, but if you take a closer look to BCM2712 system on chip, you can see that it's not a monolith. It's composed of miniature electric circuit together with probably very small chip, and on the top of it it's some kind of metal sheet curved a little bit, and this is a very small piece of metal and it provides cooling. It's like a small cooler, so it was immediately clear to me that if I blow air to this shit, it would be able to dissipate enough heat and there would be no need for large cooling ribs. But of course it works also vice versa. If you want to have passive cooler, you can also do it, but then you have to stick very large cooling ribs on the top of it. But in my case it was not needed. I just want to run this Raspberry Pi at 2.4 gigahertz, which means normal operation. So I mounted a relatively large fan that was a leftover from a broken power supply unit of a standard PC, and I put it on top and I drilled quite a large opening into the case to enable a direct airflow to the BCM27 system on chip. It turned out that it was even cooler running at normal conditions than the one that was cooled by the original Raspberry Pi 5 cooler. Interestingly, it's even better if you install an operating system that is unable to control the fan speed, like Windows 11. And in this case, if you've used the original Raspberry Pi cooler, its fan would have turned with a maximum speed constantly, which is probably not designed for. It's only designed to kick in when the temperature rises above 60 degrees. But in this case, it would have turned constantly. But if you have a large variable speed fan that can turn at the minimum RPM to cool your system, then the wear would be minimal. But if needed, I could have also designed the fan control circuit to be able to ramp up the speed to the maximum using 12 volts power supply, and in this case Raspberry Pi 5 might even have a better cooling than with the original cooler. So far I have been very satisfied with both the cases. They both perform perfectly and I like them very much. But Raspberry Pi 5s do have a deficiency. They are designed with power on button. Their power management controller, the A1991, can turn on and off the system on chip with an inbuilt or with an external power button. But if you unplug your Raspberry Pi 5 and you replug it again, it would start regardless of the power state it was on. After every power outage, your Raspberry Pi 5 would be running, and you might not like this. So I've designed my own power on management controller based on ESP32 module, and you can watch this video next to see how to build it yourself. It's very useful because it not only prevents Raspberry Pi 5 from starting when you don't want to be started, but it also enables you to start it remotely and prevent others from using it if you don't want to. So you can lock it very effectively with your smartphone or any other Wi-Fi device. Hearing all this, you might be wondering whether 3 ampere 5 volt power supply that you use for your Raspberry Pi 4 might run Raspberry Pi 5 as well. And of course I can confirm, I've also tested it. It runs perfectly, but be careful about attaching various USB devices to your USB ports. If you, for example, attach an external disk with its own power supply, it wouldn't matter. But on the other hand, if you attach an external disk with a controller that actually draws power from your USB port, then it would matter. And it would matter very much because if you attach also a hard disk, it needs power for its motor and so on, and it's quickly too much. So be careful what you attach. The same goes for the hats. If you attach a hat that is power hungry, it won't work either. But otherwise, if you are using just your Raspberry Pi 5 with only one SD card inserted into its slot, it wouldn't matter actually. You can run it with 3 ampere 5 volt power supply with no problem. Thank you for watching. Press like and subscribe buttons if you've liked the video. The next video is coming soon.